Hello everyone, my name is Sanjeev, and today we're going to be looking at SAT Math, problem solving, and data analysis, more specifically evaluating statistical claims, observational studies, and experiments. And as always, we have a set of 5 hard difficulties questions. I guess I can't say always because last time we had a set of 4 questions. Anyways, moving on to our first question, it says a sample of 40 fourth grade students was selected at random from a certain school. The 40 students completed a survey about the morning announcements, and 32 thought the announcements were helpful. Which of the following is the largest population to which the results of the survey can be applied? Okay, so what do we? So when we're looking at what is the largest population to which a result can be applied, we're looking at what is the broadest thing that still fits the category that was selected from. So if we look here, we have a sample of 40 fourth grade students from a certain school. Okay, so the broadest thing that still fits it is all fourth grade students at the school. Okay, I didn't explain that really well, but think of it this way. If you're putting the 40 students that were surveyed, yes, that is definitely an option, but it's not super broad, right? So A is one thing that it is applied to. Okay, all students at the school. Well, the thing is, if we think about it, only the fourth grade students were surveyed, right? 40 fourth grade students. So what if the fourth graders think, oh, well, the announcements have nothing to do with us. The rest of the school is like, well, it doesn't include fourth grade announcements, but it has relevant information for fifth graders or third graders, right? So then third graders might say, oh no, it's really important, while fourth graders think, no, it's not really that important. Here, most people thought it was helpful, but the opposite might be true. In third grade, they might have been like, it has no information for us, so that means that this proportion would not be valid, right? So that means we cannot do all the students in the school. And then all fourth grade students in the country in which the school is located. Well, obviously, sorry, in the county. Obviously, this can't work either because one school might have a more accurate representation for information for fourth grade students, while another school might be more focused on fifth grade announcement instead. Moreover, it's kind of more broad than all students in the school, and we already ruled that one out, so we have to X out D as well. So the answer to this question is B. That might be a bit hard to understand, but just think of proportions. Like, is a proportion going to be same in which level of this problem? Moving on to our second question, it says a trivia tournament organizer wanted to study the relationship between the number of points a team scores in a trivia round and the number of hours that a team practices each week. For the study, the organizer selected 55 teams at random from all trivia teams in a certain tournament. The table displays the information for the 40 teams and a sample that practiced for at least 3 hours per week. Okay, so which of the following is the largest population to which the study can be generalized? Okay, so here's what I would say. I would say for this one, we take the same approach as our previous question. So, what is being surveyed? Okay, what is being surveyed is what is being surveyed? Wait, let me. Okay, yeah. So what is being surveyed is your is oh come on. Okay, is 55 teams from random from all trivia games in a certain tournament. Okay, so if we look here, what is the broadest thing that can be generalized? If we look here, we see, a trend, right? We see that as time increases, right, more people score more teams score more points. Like you can see at 14 points or more, teams that studied more than 5 hours have a lot more proportion of people like that get more points than people who only studied 3 to 5 hours. This can be generalized a bit more with say 1 to 3 hours. We can assume that people will gain even less points than the people from 3 to 5 hours. So technically, all that we can generalize is D. All trivia teams in this tournament, since it can be generalized a bit further than just your, hours that are at least 3 hours, because the remaining 55 trivia teams in the sample can also be generalized. So all trivia teams in the tournament is the right answer for this one. This one, for these types of questions, honestly, what I would say is you just need to get an instinctual level type of answer choice, well, instinct for this, because you just need practice in order to solve this type of problem. Moving on to our third question, says a psychologist designed and conducted a study to determine whether playing a certain educational game increases the middle school students' accuracy in adding fractions. For the study, the psychologist chose a random sample of 35 students from all students at one middle school in a large city. The psychologist found that the students who played the game showed a significant improvement in accuracy when adding fractions, which is the largest group to which the study can be generalized. Okay, so this is the same kind of approach as the last problem. So what's the psychologist surveying, right? Okay, so we look here. We have a random sample of 35 students from one middle school in the city, in a large city. And moreover, it says all students. It's X'd out here, but all students is here. So that means that grade doesn't matter, right? So if we look here, what can be generalized? Can you generalize all students in the city? Absolutely not, because you have some college students as well. You have elementary students. So, like this game cannot be applied to other grades that are not in middle school, right? And by all students, I mean all students in the middle school. So D doesn't count. So all middle school students in the city. Okay. Well, what if one middle school is a middle school that is STEAM focused? It's a STEAM middle school. Can that middle school? Well, the people there will obviously have increased fraction accuracy compared to students in a normal middle school. So that means that the proportions are going to be different. So the study cannot be generalized to all middle schools in the city. However, it can be generalized to all students in the school, because we are selecting a sample of 35 random students from all grades in that one school. So the students from there, what we have our 35 is just a proportion or a sample from the students in the school. So it can be generalized to be all students in the middle school. Okay, moving on to option choice. Moving on to question 4. We get near the end of the U.S. cable news show, the host invited viewers to respond to a poll on the show's website that asked, "Do you support the new federal policy discussed during the show?" At the end of the show, the host reported that 28% responded yes and 70% responded no. Which of the following explains why the results are unlikely to represent the sentiments of the population in the United States? Well, okay. Well, the thing is, the only people that are attending this poll are the people who are in this website, or the people that are seeing this cable news show. And the thing is, with cable news show, often there's a lot of bias involved in these shows. That means that the audience that use these types of shows are also biased in that sort of way. For example, if you're it's kind of like a community, right? So if you have people that love bananas in one group, right? And then you have another group that I should put it like hates bananas. These are terrible banana drawings, by the way, but this is the best I could do. Obviously, the people who hate bananas are going to be coming into this group, right? And people who love bananas are going to be coming into this group. So if you're going to be asking this group, are bananas the best fruit or not, obviously it's going to have a higher proportion of people who love bananas compared to, say, this group, right? So that means that given that this bias exists, we cannot have this sort of stuff, right? So basically what this is meaning is that it's not a random sample. There's lots of bias in here, right? Okay. And also, to be fair, there is not a 50% yes and a 50% no, but that's just because some people did not respond. The real choice would be answer choice B here. Moving on to question number 5, we have to determine the mean number of children per household in a community. Tabitha surveyed 20 families at a playground. For 20 families surveyed, the mean number of children in the household was 2.4. Which of the following statements must be true? Okay, so answer choice A, the mean number of students per household in a community is 2.4. Answer choice B, a determination about the mean number of students per household in a community should not be made because the sample size is too small. C, the sampling method is flawed and may produce a biased estimate of the mean number of students per household in a community. The sampling method is not flawed and likely to produce an unbiased estimate of the number of students per household in the community. Okay, so, well, the thing is this, first of all, is this a biased estimate or an unbiased estimate? Well, if we look here, we're looking at 20 families in a playground, right? So what are the people that are going to be attending the playground? Well, obviously, the families that are going to be attending the playground probably have kids, right? Because normally you don't see adults just for fun just going to a playground unless it's for, say, walking. So we can assume that it's going to be biased. So we can immediately eliminate D, right? And because of that, the mean number of children per household in the community is equal to 2.4. That's probably not true because, again, the people who are coming here are more likely to have children. Okay? Yes, I would say the sample size is too small. However, if the main problem here is that the sample method is flawed, I would recommend that you should increase the sample size. However, if per se it wasn't, it wasn't the park, but rather, I don't know, 20 students across 20 families across the community, the sample method might not be flawed. It could still produce some inaccuracies. However, I would say it would be more accurate than having this flawed sample. So the more pressing answer choice would be C. This one is a bit more confusing than the previous one because you had two answer choices that seem correct. So in this sort of situation, in all sorts of things with SAT, whether it's your reading and writing answer choices or your math, choose the one that's more likely to be true, right? So that's how I would say. It's a tip that will help you with SAT, and don't second guess yourself either, unless you absolutely know that the answer choice that you chose was incorrect the first time around. Do not change it, because that your gut instinct is probably more right. Anyways, that's all I have for today, and have a great day, and I hope you learned something from this.